Okay, pool people, today we're gonna check the water chemistry. We have all of our vials pre-filled here to the 10 milliliter mark. We're gonna be checking for phosphorus, specifically P, PO4, and we'll do pH, alkalinity, calcium hardness, and might as well check the chlorine levels as well. First thing we need to do though is get the phosphorus test going. Phosphate 1. This takes 10 minutes in the vial after you've mixed it. So that's why we need to start with the phosphorus test. Gotta crush it up nice and good. Okay, there's the first part. Here's the second part. You can tell on these guys, phosphorus 1 and phosphorus 2. And you can tell their best buy date is February of 2029. So you really want to make sure that these aren't expired so you get an accurate reading. And this will turn blue if there's a lot of phosphates or phosphorus in the water. But again, it takes 10 minutes. And we're 2 minutes into this video. So at minute 12, we will test. And we've got hummingbirds. Okay, that's going. Let's start with a blank. We'll go to chlorine. Here's DPTXF for free chlorine. And you just put it right in here. Even though we already know there's no chlorine in the water because it is a natural swimming pool. This does not require any time. You read it right away. Put the cap on, insert sample, press OK. All right, free chlorine. So from the incoming tap water, we are still at 0.15 parts per million of free chlorine in the water. So that is kind of messing with the microbiome a little bit. That's why we have a little bit of an algae bloom out there. Once the biofilter rematures, it will all balance out. Now, XT for total chlorine, you add the XT to the XF, mix again. Okay, now we're gonna go back, choose test, go to chlorine total and read. Let's see on here, total chlorine is reading 0.05 parts per million. So that means we have no combined chlorine for sure, but there is a 10 part per million difference between what our total chlorine is and what our free chlorine is reading. So that's obviously an error. I would err more on the side of there only being 0.05 parts per million of chlorine in the water. Next, we will do pH. For that, we need phenol red right here. pH also doesn't need a timer, so we will just dive right in to the testing. This one turns red. Okay, go down to pH, and we are at 8.3. Again, that is very natural. In our bio pools, we can expect to be anywhere from 7.8 to 8.5 on the pH scale, but that is because our alkalinity, which we are going to do next, is always in balance. So the reason why in a chlorine chemical pool, we need the pH to be a little lower, around 7.2 to 7.8, is because it won't work. Chlorine won't work if the pH is too high. So we're gonna get our alkalinity test here. This turns green, give it a good crush. And I believe this needs 2 minutes. So while we're prepping this, we're gonna start with the calcium hardness because calcium hardness also requires 2 minutes of resting time. We're about 4 minutes away from testing our phosphorus. I like to make sure it's well mixed. Okay, while that is resting, we're gonna do calc call number 1 for calcium hardness. There's part 1. And calc call number 2. That will wait 2 minutes. Alkalinity should be ready. Go down to total alkalinity, test number 007. And we are at 100. Between 80 and 120 is the ideal range. So boom. We are perfectly alkaline at 100 parts per million. Again, that's green for alkalinity, red for pH, or pink. This is calcium hardness. It's kind of orange. Test number 8, calcium hardness. I believe we can wait about 30 seconds before checking. This is our TDS meter we will be using, except the screen is kind of broken, so I don't know how well you guys are going to be able to see it. Here we can actually fill up this bowl here. This water's from the pool. Get our TDS really quick. I believe this says 594, 594, which is not bad at all. Let's check our calcium hardness. 158, pretty much the same. 150 is perfect for natural water. Chlorinated pools, they like to see between 200 and 400, but that's primarily because calcium hardness continues to raise in a chlorine chemical pool, and it does not in our natural pool. The biofilter will sequester any excess calcium and then get dumped with the backwash. Oh, little tint of blue I see. We may have more phosphates in our water than we think. All thanks to the city of Phoenix, I'm sure, incoming tap water, which we should test next. Okay, phosphates. Yes, very high, PO4. We want to specifically look at P. P is most important. Say hello to the hummingbird. But yes, we are at 180 parts per billion. That is 0.18 parts per million. We like to see that at 0.01, at only 10 parts per billion. So that explains why we are having a little bit of an algae bloom out there. And yes, one thing that would help our biofilter that is just gravel would be some potted plants. However, every time I've tried, they struggle to even survive. So this is kind of where we're at. Let's see where we ended up on the LSI, Langelier Saturation Index. What was our pH? Sorry, calcium hardness was 158. And okay, so we should be here. Total alkalinity was 100. Calcium hardness was 158. And water temperature, I believe we're at like 83 degrees. So yeah, but our pH was reading 8.3. So we are off on our LSI index by about -0.5. Interesting. Could only speculate as to why. We'll have to get with BioNova and see what they think. Okay, now let's check the tap water. Before I do that, I need to change the sample ID to tap water. We're going to check phosphates again on the tap water. Here's our blank. Here's our sample. A little bit of a blue tint. All right, 0.35 PO4 and 0.12 of P. So before we were at what, 0.15? Let's go back, check the log. That's our tap. And then yeah, 0.18. So out the tap is 0.12, and we are just slightly higher in the water in the pool at 0.18. And the only reason we're not any higher is because the algae is eating it. So what we could do is use a phosphate remover, add it to the pool, mix it around, it'll clump all the phosphorus together, and then we'll vacuum it out into the cartridge filter to get dumped and help it clear right up. Normally when the biofilter is fully mature, our biofilters are able to handle any amount of phosphorus and outcompete the algae for nutrients, even if the phosphorus gets that high. The biofilter just needs time to be able to sequester that phosphorus. It doesn't consume it, but it traps it. And right now, because we just backwashed and we had a bunch of tap water come into the pool, and our tap water is at 0.12 parts per million of phosphorus already, plus with all the wind causing evaporation, adding a bunch of water in as well, we are just a little bit behind, but the biofilter will bounce back. So we'll be doing a phosphate remover and or adding in some plants into the biofilter. So stay tuned. Follow along to see what happens next.